Hey everybody, today we're going to be taking a look at how to multiply decimals. And we're going to start off with the example of 1 2/10 multiplied by 5. So we've probably heard about the rule where you just multiply your two numbers and then count how many digits are to the right of the decimal point. Today I want to explore why that works. So with our original multiplication, we've got 1 2/10 times 5. Let's take this back and let's move to some numbers that we're definitely comfortable with. Let's just try 12 times 5. So we know from our standard algorithm that we can multiply our ones place, and 2 times 5 is 10. So we write our 0 and regroup. And then we multiply our ones by our tens. 1 times 5, or 5 times 1, is 5. Plus the 1 that we regrouped is 6. So we get a total of 60. Okay. 12 is 10 times bigger than 1.2. And you can try it on your calculator. If you have 1.2 and you multiply it by 10, you're going to get 12. Or if you took 1.2 and added it to itself 10 times, you would end up at 12. So it makes sense that our answer for this problem, 12 times 5, would be 10 times bigger than our answer for 1 2/10 times 5. So if we follow our algorithm, 1 2/10, and then we'll multiply by 5. Well, 5 and 2, multiply those, we get 10. Of course, we regroup again. 5 times 1 is 5. Take our 1 that we regrouped, add it to get 6. And we've ended up with 60, but we've got that decimal that has been moved to the left one place with 1.2. So we move our decimal here, and we get 6 0/10, or just 6 even. Now we could take this a step further and now try 1 2/10 times 5/10. And if my logic stands, then our number will be 10 times smaller. Our product will be 10 times smaller than our previous product because our 1 2/10 stayed the same, but our second factor of 5 got 10 times smaller when we made it 5/10. So let's stack and multiply following our standard algorithm. And of course, 5 times 2 is yet again 10. Regrouping. 5 times 1 is again 5. And add that 1 that we regrouped. Now we've got one number and another number to the right of the decimal. So instead of keeping our decimal over here to the right like we're used to, we are going to move it 2 units to the left, and our new answer becomes 6/10. So we went from 6 for this product to 6/10 for this product. So that kind of shows one of the reasonings behind why we move that decimal according to the number of digits to the right of the decimal point. I'm going to do one more example for those of you who would like to see it. So we're going to try 1 3/10 times 1 9/10. You can see I've already stacked my numbers to multiply them in the standard algorithm. We're going to do 9 times 3 first, which is 27. So we put our 7 here and regroup. 2 goes over here. 1 times 9 is, of course, 9. Add 2, and we get 11. No need to regroup because I don't have any further numbers to multiply. No numbers over here. So now I can take this 1 and start multiplying. 1 times 3 is 3. And 1 times 1 is 1. And now I can add those two numbers up. 7 plus nothing is 7. 1 plus 3 is 4. And 1 plus 1 is 2. Now the question stands, where can I put my decimal point? So we're going to count. I've got 1 digit to the right of the decimal here, 1 digit to the right of the decimal here, for a total of 2 digits to the right of my decimal. So I'm going to have 2 digits to the right of my decimal in my final answer. Now let's think to ourselves, does this make sense? Okay. I know that 1.9 or 1 9/10 is very close to 2. And I know that 1 3/10 is very close to 1, but a little bit bigger than 1, right? So we would expect a number that is close to 2, but a little bit bigger than 2, because we're taking that close to 2 number and multiplying it by a number a little bit bigger than 1.